Today's lesson is curved mirrors or spherical mirrors, right? If I ask you what is a mirror, you will answer mirror is a surface, or mirror is a reflecting surface, right? So if I ask where can you see mirrors, so you'll say, oh, we can see mirrors in homes, in house, in salons, in side mirrors of vehicles, and in various shops and all, right? So that's the basic knowledge. So in this lesson we are going to talk about the curved mirrors, right? That means not the normal mirrors, the mirrors with the curved reflecting surfaces. So as you can see here, there are two types of mirrors, as concave mirror and convex mirror, right? So how do you identify these two separately is, if you see this concave mirror, there is always a cave like reflecting part. As you can see with this arrow, this side, the arrow the side shown by the arrow represents the reflecting sides, while this convex mirror, here this part is the reflecting side. So always if the concave part is the reflecting part, we are calling it as the concave mirror, and if the convex part is to the reflecting side, we are calling that as a convex mirror, right? So if we take the origin of this concave or convex mirror, it's a part of a sphere, right? As you can see in the diagram, when you take a concave sphere, right, the concave mirror is only a part of the whole concave sphere, right? As you can see, the principal axis joins the center of the curvature and it forms the diameter of this sphere, right? So pole is the place in which where principal axis meets the concave surface, right? So when you take concave surface is inside the sphere, but in convex mirrors the reflecting side is towards the outside, right? So as you can see here, principal axis lies as the diameter of the sphere, and as you can see, center of the curvature and the pole, right? So we are calling the midpoint of the center of the curvature and the pole as the focal point. So if you draw an imaginary line here, you can see this will be the focal point. If you draw an imaginary line here in between center of curvature and the pole, you can get the focal point, right? So focal point plays a major role in reflecting light rays. If light rays come parallel to the principal axis, it will move, or it will be diverged as it is coming from the focal point behind the mirror, right? So always concave mirrors converge the parallel beam of light, right? Convex mirrors diverge the light always, right? So that as you can see it here, as convex mirrors diverge the light rays, you can see the image will be formed behind the mirror. If there is an object in front of the mirror of a concave mirror, you can see the image will be enlarged. But in convex mirrors, always the forming image will be diminished. That's because images are formed behind the mirror. So this will be the size of a image formed by the convex mirror. So always convex mirrors form diminished images, right? So I have made you a note here which I discussed earlier, right? You can get it through the link I given in the description. Okay. So let's go to the next subtopic, reflection from a concave mirror, right? So here There are some principles which are used to draw ray diagrams formed by convex or concave mirrors. There are basically 5 rules, right? Let's talk about each one of them separately. Right. Number 1, rays coming along the principal axis of a concave mirror return along the principal axis after reflection. That means if you have a mirror like this, a concave mirror, as you can see it here, this part is the mirror, right? As you can see, we are not drawing whole spherical part, we are just drawing a dotted line and then we are drawing a small concave mirror, right? So this whole thing, this whole dotted line thing will represent the mirror, right? On number 2nd rule, it says that rays coming parallel to the principal axis pass through the focal point after being reflected by the concave mirror, right? So concave mirrors always converge the light rays. So when a light ray comes parallel to the principal axis, what will happen? It will be converged so that all the light rays pass through this focal point, right? So focal point is the half the distance between center of the curvature and the pole. So that will be the 2nd rule. In 3rd rule, as you can see it in here, rays coming towards a concave mirror through the focal point are reflected parallel to the principal axis, right? That's the opposite of the 2nd rule, right? So in the 2nd rule, light ray came parallel to the principal axis and went through the focal point. So in the 3rd rule, when a light ray passes through the focal point and gets to the concave mirror, what will happen? It will be reflected parallel to the principal axis, right? In 4th one, as you can see it here, when a light ray coming towards a concave mirror through the center of the curvature, it will be reflected back through the center of the curvature, right? So as I told it in first one, when a light ray comes along the principal axis and if it hits the pole, it will be reflected along the principal axis, right? In this 4th one, what happens? That's also an reflection which goes along the incident ray, right? So when the incident ray is coming through the center of the curvature, hits the mirror, it will be reflected along the center of the curvature. So there will be no converging of the ray. It will go along the same path where it came, right? So the 5th rule, or the last rule for reflection of concave mirrors, is this: rays making a certain angle of incidence with the principal axis will be reflected back with the equal angle of reflection, so that simple I will be equal to simple R. So let's talk about the images formed by the concave mirrors. So as you can see here, I have given the note. First, you have to identify what are real images and what are virtual images, what are upright images, what are inverted images, and the position with respect to the mirror and all, before we are going to draw the ray diagrams of concave mirrors, right? As you can see, there are 2 types of images formed by a mirror or a lens, right? In both the cases, we will get 2 kinds of images. One is a real image and another one is a virtual image, right? In real images, the images formed can be taken onto a screen. For an example, if you use a mirror and if it forms a real image, and if you keep a screen on the place where it forms the real image, you can get that image onto a screen. It's like a normal TV screen, you can get the picture there, or the image there, right? But if it's a virtual image, you can't get it, right? For an example, if I say it like this, if you go in front of a mirror, right, there will be the image formed in front of you, but you can't get that onto a screen. That's because it is formed as a virtual image, right? Real images are so different that real images can be taken onto a screen, right? So that's the difference between the real image and the virtual image, right? So, and there are kinds of upright images and inverted images, right? So you have to know these technical terms so that you can understand the lesson and the images formed by mirrors as well as lenses, right? So if we talk about upright and inverted images, right? Let's say you have a tree as an object, right? So this is the object. If it forms an upright image through a certain thing, that thing can be a mirror or a lens, right? If it forms the tree upside down, we are calling that as a inverted image, right? But if it forms like this, if it forms the image with the same orientation as that of the object, we call it as upright image, right? So if the image is upside down, we are calling it as inverted images, and if the image has the same orientation as that of the object, we are calling that as upright images. As we learn the technical terms, let's move on to ray diagrams, right? You should be able to draw these ray diagrams along. So as you can see in these diagrams, there are 6 places we are going to talk about that the object can be kept with respect to the mirror, right? So that position of the image, nature of the image, size of the image depends on this position of the object with respect to the mirror. When the position of the object is changed, the nature of the image, the size of the image, the position of the image will also be changed, right? So let's take number 1, where object is in between the mirror and the focal point, right? So as you can see it here, pink color arrow shows the object, right? So as you are looking through the reflecting side, the eye is on the right hand side and the image is formed behind the mirror, right? So if you apply those rules which we learned before, you can get the position of the virtual image, the image that is formed by this object. As you can see it here, a light ray which comes parallel. As you can see it here, the light which comes parallel to the principal axis move through the focal point and it is going through the eye. And the other light we are taking is the light ray that passes through the center of the curvature. So as you so if you remember that the light ray that comes from the center of curvature will be reflected back through the same path. So this shows that thing, the light ray which comes through from the arrow, the light ray which comes from the object reflects back through the same place from the center of the curvature and it will move to the eye. Here, when the object is kept in between the mirror and the focal point, what happens? Even though that is a concave mirror, right, the light rays will be deflected away, right? That's due to the position of the object, right? So that the image can be taken by extend these light rays which are coming to the eye. As you can see it here, we have extended the reflected rays so that they meet at a point, right? This image is a virtual image, that means this can't be taken into a screen. And if you consider the size of the object and the virtual image, you can see that the virtual image is larger than the object. So we say image is enlarged and image is upright. let's move on to the second position, that is object which is kept on the focal point. As you can see it here, we take the arrow as the object, right? So when a light ray comes parallel towards the principal axis, it will be reflected towards the focal point, as well as the light ray which is coming along the center of the curvature will be moved back, right? So as you can see it here, these light rays are parallel to each other. These light rays move parallel after being reflected, right? So that we say the image is formed at infinity. So that an image formed at infinity, we can't clearly state the nature of that image, right? So as you did it before, you can draw dotted lines behind this mirror, so that will also be parallel, but it will also form at infinity. As we drew before, according to the laws, the light rays will be parallel, will be gone parallel after being reflected. So that we assume, or we cannot tell the nature of this image specifically, but we assume that these parallel rays meet at infinity and it will form a very large image and it will be inverted, right? Let's go to the third position. The small red color one will be the object. So if you draw light rays according to our previous rows, you can see the rays which is coming parallel will be reflected back through the focal point. Light rays which are moving parallel to the principal axis will be moved through the focal point, and the light rays which are seen to be coming from center of curvature will be moved along through the center of the curvature, so that these two light rays will meet at a point, and this point will be the tip of the image formed, right? So compare the object and the image here. As you can see, image is inverted, that's an inverted image, and you didn't draw any dotted line, that means image is not formed behind the mirror, so image is formed in front of the mirror, right? So this will be a real image, meaning that this image can be taken onto a screen. So if you keep a screen here in this place, you will see that the image of the arrow lies on the screen, right? So this will be a real inverted enlarged image, right? So that was the third one. Let's go move on to the fourth one, the object which is kept on the center of the curvature. So as you know, when the light ray which is coming parallel towards the principal axis will move through the focal point, right? And the same thing happens, the light ray which is coming through the focal point will move parallel to the principal axis. See, at last image will be formed on the same position of that of the object, right? So if you compare the object and the image, you can see height of the object and height of the image will be similar, so there will be no any enlargements or there will be no any diminishments, right? And also image is upside down, meaning that image is a inverted image, so this will be a inverted real image, right? Let's move on to fifth part, that is object is at a point beyond the center of the curvature. That means object is kept little aside from the center of the curvature, right? So if we draw light rays again, the light ray which comes parallel will move through the focal point, and the light ray which is moving through the center of curvature will move again through the same path, so that the two light rays meets at this point. If you compare the object and the image again, the size of the image is smaller than that of the object, so we say it has a diminished image. And if you see the orientation is different, right? That means this image is upside down, so we call it as a inverted image, inverted diminished image. The image is formed in front of the mirror, so that this is a real image. So if you are asked to write the features, you have to write those as diminished image, inverted image, and a real image. Right, let's move on to sixth place, that is the object which is kept very far from the mirror, right? So we say that the object is kept at infinity, right? What will happen here is the opposite thing as the second example. Here, when the object is kept at focal point, the image formed at infinity. Now we have kept the object at infinity and the image will be formed at the focal point, right? So here also we apply the same rules and draw the position of the image. If we talk about the nature of this image, this is a diminished image and it is inverted, right? So if you consider the nature of this image, this will be inverted image, smaller than the object, and it will be a real image, right? So those are the 6 main position in which we talk about concave mirrors, right? Here is a chart which gives a summary of position of the image, or real or virtual nature, upright or inverted, and the image size. Hope you take it as a summary. So let's move on to reflection from a convex mirror. So as you can see it here, there are also some basic rules when you are drawing ray diagrams reflecting from a convex mirror, right? Number 1, light rays which are coming along the principal axis will move along the same path, same as that of the concave mirror earlier. Here, these both, this part A and part D, these rows will be similar as that of the concave mirror, but the only difference is that previously we talked about the light rays which are coming towards the concave mirror will be converged, but in convex mirror what happens, when the light rays comes, the light rays will be diverged. That means it will be dispersed away from each other. The light rays will move as it is coming from the focal point. So if a light ray here comes parallel to the principal axis, when light ray comes parallel to the principal axis, it will move away so that it is coming from the focal point, right? Same applies for the part C rule, that is when a light ray comes as it is hitting the focal point, it will be gone as a parallel line towards the principal axis. So these are the 4 main basic rules which you need to draw ray diagrams. right? So there's a special point. That special point is, though they have a different positions, different natures, and different sizes of the images formed in the concave mirror, but in convex mirror you will get only one image, that is a virtual, diminished, and an upright image always, and that will not change. So if you take a convex mirror, even though keep the object near the mirror, at the focal point of the mirror, or away from the focal point, or on the center of the curvature, or at infinity, anywhere, you will get the same nature. It will always be upright, it will always be virtual, and it will be diminished. Diminished means smaller than the object, right? If I draw you this, this is the object. The light rays which moves parallel towards the principal axis will be reflected as it is coming from the focal point. So here light rays which is coming towards the center of the curvature of the mirror will be moved again to the opposite side as this way, right? So that always there will be a virtual image found behind the mirror. So what's the meaning of virtual? You can't take that image into a screen, right? So that's all regarding spherical mirrors. Let's talk about refraction of light in the next episode. Thank you for watching.